A cognitive therapy for anorexia was tested in 15 girls. The weight changes of the 15 girls had a sample mean of X bar of 5.31 and a standard deviation of S of 10.82. Using the hypotheses, the null hypothesis being the mean is equal to 0 and the alternative hypothesis being the mean is not equal to 0, about the population mean weight change mu, what would be an example of, to give an example of a type 1 error that would occur in the scenario if the significance level was 0.10. So best way to do that is just type this. The p-value is 0.08. This will be given no matter what answer choice. Therefore, the null hypothesis is rejected. The null hypothesis is rejected when in reality the therapy does not have a positive effect on the patients. Then to give it an example of a type 2 error that would occur in this scenario if the significance level is 0.07. Again, this will be given no matter what answer choice is used, but the p-value is 0.08. Therefore, the null hypothesis is not rejected, when in reality, the therapy has a positive effect on the patients. For question number 14 here, an electrical engineer wants to compare the resistance of 4 types of wire made from different materials. 5 wires of equal lengths and cross-sectional areas are prepared for each of the 4 wire types. Each section of wire is randomly tested by sending a current through the wire and measuring the resistance. After calculating the data and analyzing the results, she reports that the F ratio is 1.076. Assuming that the conditions required for an ANOVA are satisfied, what is the F value having a p-value of 0.05? What would you conclude using an alpha of 5%? So for this, we need to find the F test statistic. And we could do so using f.inv.rt of the p-value 0.05. The first degree of freedom. We are told that there are four different wire types. So 4 is the number of groups that we have. The first degree of freedom is 1 less than that, so 3. The second degree of freedom, there are 5 wires of equal length and cross-sectional areas are prepared for each of the 4 wire types. So because of that, that means there are 20 total. So the number of groups is 4, the total number is 20. So 20 minus 4, the second degree of freedom is 16. So typing that into Excel, will give us a value of 3.24. 3.24 is much greater than 1.076. So, because of this, we would have do not reject the null hypothesis. Why is that? Because this F ratio would need to be greater than the test statistic. It is not in this case. For question number 15, we have an introductory statistics course where x equal the midterm exam score and y equal the final exam score. Both have a mean of 75 and a standard deviation of 13. The correlation between the exam scores is 0.75. We first want to find the regression equation. And there are two equations to keep into mind here. And the first being the slope equation. That takes the correlation coefficient and multiplies it by the standard deviation of the y variable divided by the standard deviation of the x variable. So the correlation coefficient here is 0.75 and both standard deviations of 13. These simply reduce just to make a slope of 0.75. The y-intercept takes the average y value and subtracts it from the slope times the average x value. So 75 minus 0.75 times 75. A whole bunch of 75s. You do this out, you get 18.75. Because, hey, why not, right? The line of best fit of the regression equation, then, would be y hat is equal to 18.75 plus 0.75 times x. To find the predicted final exam score for a student with a midterm score of 75, and then with 85. So we will need to do both of these. So y hat for 75 first. If we put 75 into this, we would have 18.75 plus 0.75 times 75. If you were to do this calculation out, you get a value of 75. 0.00, rounded to 2 decimal points. Y hat for a exam score of 84, this would be 18.75 plus 0.75 times 84. Do that out on a calculator, you get about 81.75. A whole bunch of 75s, right? A quick interpretation of both of those values, though. Let me put a little bit more space here, just so I can have more space to write. This would be that the predicted final exam score for a student with a midterm score of 75 is 75.00. The predicted final exam score for a student with a midterm score of 84 is 81.75. Question number 16 here. The menu tab output, meaning this data right here, shown below is the result of a regression analysis for 27 homes relating y as the selling price in dollars and x the size of the house in square feet. We first want to show all the steps of a two-sided significance test of independence, and to give the correct assumptions that need to be made. So for this, again, best for me to type this out. We want to assume randomization, linear trend with normal conditional distribution for y, and the same standard deviations at different values of x. Okay. The null hypothesis, the variables are independent, and then the alternative, and I'll write what that means in 1 second. The alternative hypothesis, the variables are dependent. Again, I'll write what that means. And I'll write what that means in 1 moment as well. That being that for the independent, the slope is going to equal to 0. And for the dependent, it is non-zero. And we can find the t-value from this, right? The t-value, since we're referring to this linear regression model, we are using the test statistic related to the slope. So size is a variable, and well, constant is a constant. So the t-statistic for size is 8.916. So t-value is 8. I'll write it up here. 8.916. And then the p-value we could also get from this of essentially 0, since that's all we were given. And as such, we could write our conclusion. We're going to reject the null hypothesis and conclude that the variables are dependent. Why? That's because our p-value is less than the level of significance of 5%. Part B of this wants to construct a 95% confidence interval for the population slope. So for something like this, we need to pop into Excel for this. So actually, let me put these values back up on here. So we were told that the slope was 56.151. The lower bound of this we're going to get by subtracting the t-value. So t.inv.2t of the p-value. So, well, I shouldn't say the p-value. Since we want a 95% confidence interval, 100 minus 95 makes 5% or 0.05. And the degree of freedom, we were told that there were 27 homes. So 27 minus 2, the degree of freedom is going to be 25. And we're going to multiply this by the standard error of 6.298. So let me just very quickly write that equation out that I just used. We took the slope, and we're going to add and subtract the t-score at that level of confidence of 95% times the standard error. So subtracting those values gave us a t-score of 43.18. And then if we were to add them, so just very briefly change my formula to a plus, this gives us a value of 69.12. And that'll be the 95% confidence interval on the slope. And here, builders claim that the selling price increases $100 on average for every extra square foot. Based on what we just got for Part B, is this a valid conclusion? 100's nowhere near this confidence interval, so the answer to that is just simply no.